Alrighty, in this video, we are going to be talking about function transformations. So we are probably going to be given some weird graph like this, and then we are going to have to use transformations. For the first graph, we have f of x plus 2 and then f of x plus 2. Notice how these are two completely different functions. What you probably want to do is probably use two different colors to denote this because it's going to be on the same graph. Remember that if it's on the outside, if my argument is on the outside right here, it's either going to go up or down depending on your value here. So because this is a plus 2, I'm going to go up 2. Now, whenever we're going up 2, we are probably going to be using our reference points right here that they give us. And just go up 2 and call it a day. All right. For this one right here, remember that if I have an argument on the inside, it's going to be the opposite of whatever my sign is. So in this case, I'm going to go left 2 units. If it was this right here, this would be right 2 units. So using our black graph, I'm going to go left 2 units, left 2 units, left 2 units, and then see where that takes us. All right, for the second graph right here, we have negative f of x. So remember back in our transformation days, back in map 2, this is just going to be a reflection across the x-axis. And remember that a reflection across the x-axis means that your y value is going to be flipped. So 7, 1 becomes 7, negative 1. 1, 2, 3, 4, 5. 3 becomes 5, negative 3. 0, negative 2 becomes 0, 2. And then negative 3, 4 becomes negative 3, negative 4. And then you plot your points. Likewise, same thing here. Back in map 2, we talked about how this is a reflection across the y-axis. So this right here is negative x comma y. So your x value is being flipped. So now negative 3, 4 becomes 3, 4. 0, negative 2 doesn't change because 0, negative 2 is on the y-axis, so it just stays there. 5, 3 becomes negative 5, 3. And then 7, 1 becomes negative 7, 1. And then we graph. All right, so for this one right here, we have 2 times f of x. So this is saying 2 times the output value. As a reminder, what I'm going to do is make a table of values for these 4 points that I have. And then we'll work with those 4 points and then see how 2 times f of x, how does that change the output value? So remember that this is negative 3, 4, 0, negative 2, 5, 3, and then 7, 1. Now, this is x, this is f of x. So if I want 2 times f of x, this is just saying 2 times whatever my output value is. So 8, negative 4, 6, 2. So then I'm going to graph negative 3, 8, 0, negative 4, 5, 6, and then 7, 2. This right here is a a vertical stretch. Now, if hypothetically your coefficient here is between 0 and 1, absolute value, so it could be like negative 1/2 or something, that right there would be a vertical compression because it's going to get smaller. All right, looking at f of 2x here, we have a problem because our 2 is inside the argument. So we're going to go back to our table of values here that we had earlier. And what we're going to do is try and figure out what can I do to get, let's say, f of 2x. Okay, so if I know that x is -3 and f of x is 4, then what I'm going to do here is think about how can I get a -3 so that whenever I plug into x here, I get an output to 4. Well, hypothetically, if x was -3/2, -3/2 times 2 will give me a 4. 0, honestly, 0 is just going to be -2 because f of 0, 2 times 0 is just going to be 0, so f of 0 is still going to be -2. But with 5 here, I need to think, what do I need here so that whenever I plug in, I'm going to get a 5. That's going to be 5/2, then 3. Then likewise, what do I need to get a 7? Well, 7/2 times 2 is going to give me a 7. So that's going to give me a 1 right there. So as a reminder, this is a horizontal compression of 1/2. So a horizontal compression of 1/2. And you'll see that the x values are going to get skinnier here. So -3/2, 4 is this right here. 0, -2, 5/2, 3, so that's 2.53. And then 3/2, 1. So you'll see that my graph is definitely skinnier. So this is a horizontal compression. Now, if it was the other way around, let's say that it was f of 1/2 here, then we need to think about, okay, what do I need so that I get -3 as my x value inside the argument? So then this would be -6, because -6 times 1/2 will give me a -3. Then that there would be a horizontal stretch, so your graph is going to be a little bit wider in terms of your x values. All right, so those 5 graphs right here were kind of easy peasy lemon squeezy because it only dealt with one transformation. Whereas for number 6 here, we are going to be dealing with multiple transformations because we have a negative here, we have a 2 here, we have a negative here, we have a 2 here, and we have a 2 here. So whenever we have something like this where it's where we have multiple transformations, I always like going from left to right, thinking about what's going on and doing the transformations from left to right. Before we do that, there's also one thing that we need to take note of is that your argument, your coefficient of x needs to be 1. If your coefficient of x is not 1, then we're going to have to make it 1 by factoring some stuff out. So in this case, don't say that this is going to be a reflection over the y-axis and then left 2, because that's going to be wrong. Because what's going to happen here is we're going to take out a negative. And notice how we still have that reflection over the y-axis, but instead of it being left 2, it's technically going to be right 2. And notice how here we have a coefficient of 1, so that's good there. All right, looking at the table of values that we have here, this is going to be handy for us whenever we try and do this transformations. So going from left to right, the first thing that I notice is that this is a reflection across the x-axis, which means that your y values are going to become negative. So your x value stays the same, your y value becomes negative, and that's the first thing. The second thing is that 2, so technically you could have done this earlier too with that negative, because you're multiplying the y value by negative 2. So this becomes a negative 8. This becomes a 4. And this becomes a negative 6. And this becomes a negative 2. So that helps us with this right here, my output value. The next thing that we're going to do is this negative right here. Remember that this is a reflection across the y-axis. So this means that your x values are going to be negative. So we're going to negate all of the x values here. So that means that this becomes negative, this becomes 0, so this becomes negative, and this becomes negative. We just negated all of the x values. We have this right here that stands for right 2 units, and right 2 units will affect my x value. So this means that instead of a 3, I'm going to have a 5 now. Instead of a 0, I'm going to have a 2. Instead of a negative 5, I'm going to have a negative 3. And then instead of a negative 7, I'm going to have a negative 5. And then my last final transformation is this plus 2, where I'm going to add 2 to each output value. So negative 8 becomes negative 6. 4 becomes 6. Negative 6 becomes a negative 4. And then negative 5, negative 2 becomes 0. Obviously, you can't do the magic of erasing. So what you should probably do here is probably don't erase your original and then just make more tables when needed. Let's see. I'm going to graph 5, negative 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 2, 6. 1, 2, 3, 4, 5, 6. Negative 3, negative 4. And then negative 5, 0. It's 11:11, guys. Make a wish. All right, and then this gives us our beautiful graph right here. What I'm going to do here is, hypothetically, if you didn't want to make a table of values, you can use your reference points and use the reference points and the transformations 4 times, which is kind of a lot. So that's why I prefer using the table of values. But, you know, you do whatever works for you. So in this case, if I were to do 7, 1 here, I'm going to do a reflection across the x-axis and multiply by 2. So that becomes this right here. Then I'm going to do a reflection across the y-axis. So this becomes this right here. And then I'm going to go right 2, so that becomes this right here. And then I'm going to go up 2, which gives us this point right here. So this point in green corresponds to this point right here. Likewise, you could do the same thing for the other 3 points. It's just your preference of making a table of values or doing the transformations 4 times using your reference points. All right, we have 2 more functions, 2 more transformations that we have to do. So the first one is the absolute value function. And notice how with this absolute value function, it's the absolute value of the whole thing. Meaning that anything I see below the x-axis needs to be brought up. So I should not see anything below the x-axis. So this 0, negative 2 becomes 0, 2. And then at this point, we're just going to use symmetry and hope for the best. And this right here becomes your final graph for the absolute value of f of x. Notice how all my values, all my output values are all positive or 0. Now, we have another absolute value function right here, but notice how the absolute value is inside my argument. So let's think about values to the right of the x-axis. If I were to think about the values to the right of the x-axis, so let's say f of 1, well, that doesn't really affect anything because it's positive. Or f of 2, or f of 3, or f of 4, that's just positive. But here's where things get a little bit wonky. If I have f of -1, and I use my absolute value, notice how f of -1 becomes f of 1. Or if I do f of -2, that becomes f of 2. Or f of -3 becomes f of 3, and so forth. So essentially, anytime you see an absolute value transformation where it's inside the argument, we are just going to reflect to the right side of the y-axis right here to the left side. So in this case, if we know that f of absolute value of -1 is f of 1, and I know that f of 1 is -1, this means that my graph should look like this right here. So essentially, your final graph should be symmetric with the right side of the y-axis. So 1, 2, 3, 4, 5, f of 5 is 3, which means that f of the absolute value of -5 should also be 3. Let's see, this one right here, 1, 7, f of 7 is 1, meaning that f of absolute value of -7 should also be 1. And then at this point, graph, let's see, and then probably hits this right here. So your final graph, you want to make sure that you also include the right side. So they'll just graph the left and call it a day. Probably highlight or bold or do something in terms of the right side because it's still part of your graph right here. And notice how this right here, f of absolute value of x, your graph is symmetrical in terms of the y-axis. All right, so that's basically it. We'll do function notation in class, and then we'll do a whiteboard activity in class with the transformations.